Hello everyone, welcome back to yet another episode of our tutorial series. In this episode, we're going to make some sounds. And in doing so, we're going to also review and revise our concepts on subclasses, inheritance, and polymorphism. Those are some of the three crucial concepts in object-oriented design, and we will see how that helps us in making different sounds with different types of components. So let's get started. Okay, so let's take a look at what we've got here. Now it looks like there is a lot going on in here, but we're actually not going to use all of these in this video. I am preparing for a video for the main channel, so there's a bunch of things, additional things that are connected. For example, a couple of microphone modules here, an SD card module, which we're not going to use in this video. In this video, we're going to use these two little guys. This is called a passive buzzer. This is called an active buzzer. And we're also going to use this thing called an I2S soundboard. So a passive buzzer looks like this. It's a super simple buzzer, piezo buzzer with no oscillator. So you are supposed to do all of the sound production work yourself. Now it does have a positive and negative, so when you connect it, you need to make sure that you connect it with the correct terminals. An active buzzer looks a little different, and it is pretty loud, so that's why there's a sticker on top to sort of cover the top. Note that internally it is sealed off. It has an internal oscillator, which means it is designed to play a single note pretty loud, and that's all it does. And the soundboard that we're going to be using is an I2S soundboard, which has a small little amplifier. It actually has ports for connecting little mini speakers like this, or it also has an audio jack, so you can connect an external speaker. So we're not going to use these speakers. These are pretty tinny, doesn't sound too good. We're actually going to use an external speaker like this one, so we can hear the sound better. So those are the three things that we're going to use today. So let me show you how this would work when I run the code. Okay, I have a little bit of a code here. We're going to explain this code later on, but basically what we're going to see is the sound being played from the three different buzzers. First, we'll play through the active buzzer, and as you know that it is only able to produce a single tone. It does not let you play different tones. Then we will play the sound through the passive buzzer, and then we will play the sound through our soundboard, I2S soundboard. All right, so let's see what that sounds like. As I said, first we're going to play through and we're going to go every one of them one after the other. So here we go. Active buzzer. Passive buzzer. SoundPlayer. Okay, so hopefully you saw the difference there, that when we played it with the active buzzer, it basically played the same note 8 times. Then with the passive buzzer, we got kind of like an 8-bit, old school game type of sound. And then with the soundboard, we got full fidelity. You could do mono or stereo, depending on how you have things connected. So we're going to learn about how we do this using the Pico library, and at the same time, we're also going to learn about subclassing and polymorphism. So let's take a look at the design. Okay, so let's take a look at the design and the code to see how this works. Now, all of the classes are already in Pico library, so I'm just going to show you the design and talk about the little bit of code that we used to play the sounds that you heard just now. So the top superclass in Pico library for the buzzers is called buzzer. Now, I probably could have picked better names, but
for whatever it's worth, I called it buzzer. Now, this guy is basically a generic class. It does not really have any capabilities, right? You need a specific type of buzzer to play sounds. So this just has a name, and it's got these three generic methods to play, stop, and beep. Beep basically just plays a tone for a little bit of time and then stops. So it combines the two. Now, in order to implement these, you can implement it in ActiveBuzzer or in PassiveBuzzer. Obviously, ActiveBuzzer can't play different tones, so it simply ignores the tone. But still, to keep the structure the same, I decided to put the tone parameter in there as well. Now, of course, it's an optional parameter, so you can just say, if you have an active buzzer, just say play, and it would play its default tone. And then you could say stop. Now, these are methods that you are overriding from the base buzzer class. Same thing with passive buzzer. You have additional attributes to implement the passive buzzer, and that is one thing that you should see, that buzzer class has its own attribute name, which gets inherited by both active buzzer and passive buzzer. Attributes are always inherited. You just need to initialize it in your init. I did not include the inits in these class diagrams, but of course, there will be an init operation in all of them. Passive buzzer overrides play, stop. It inherits the beep. Both of them inherit beep directly. And it also has an additional method called set volume, so you can change the volume of the passive buzzer. Now, the sound player is even more specialized. It can do all of these, play, stop, and set volume. Obviously, it inherits beep and name from the superclass buzzer, and it has its own stuff that it creates. Now, one thing to note, though, is by definition, SoundPlayer will also inherit these guys like buzz, PWM, playing, volume, and things like that. Whether SoundPlayer uses it or not is going to be up to its capabilities. Now, it needs its own attributes, other attributes that it uses, and it has the play, stop, set volume, just like passive buzzer, but obviously implemented differently. And in addition, it has capabilities to play a WAV file, so to play actual voice or things like that. Play tone is essentially the same as play, just a different because it generates the sound and things like that. In addition, it also has pause and resume capabilities because if you can play music, you would be able to stop and resume as well. So let's take a look at the code that we used for that little demo at the beginning. Walkwe, we'll just do it in Walkwe today, but recognize that Walkwe really does not support all the three different types of sound mechanism we showed. It only supports the passive buzzer. So we will just have a passive buzzer, and it has got a positive pin and a negative pin, and you connect the positive pin to whichever one you are using, and you connect the negative pin to ground. So I can just create a ground and connect the negative pin to it. So it's super easy to connect. I'm not going to connect anything else, although I'm going to leave the code in there so you can see how that works. But recognize that, okay, so let's upload the files that we need from Pico library. You'll need the buzzer class for the active and passive buzzers. Of course, we need the log class for basically everything. And we will also need the SoundPlayer class for the I2S sound file, so you can see how this works. Remember that there is no soundboard connected here, but we should still see the code running. Now, here is where polymorphism comes into play. I've got an active buzzer created here. I've got a passive buzzer created here. And I've got a sound player created here, right? Now, what I could do is I could create an array with all three of them, active buzzer, passive buzzer, and sound player, right? All three of them in one array. polymorphism, right? You have different things in the array, and they are all different subclasses of the buzzer hierarchy. Now, what I could do is I could just go through the array of different players and just play the sounds using the play and stop methods. Now, since buzzer includes play and stop method, this would just work across all the different polymorphism, all the different shapes of buzzer without you having to do any if then else in here. And that's the beauty of polymorphism. So when I call player.play, the interpreter figures out what kind of player it is. If it's an active buzzer, it's going to call the play method from ActiveBuzzer. If it's a passive buzzer, it's going to call the pay method in PassiveBuzzer. If it's SoundPlayer, it's going to call the play method in SoundPlayer. So I'm going to run this, recognize that the ActiveBuzzer and the SoundPlayer is not going to work in the simulator because it's not supported. But at least you will see that the code just runs through it. So here you go, starts with ActiveBuzzer. Nothing happens on here, obviously, because it's not there. Let's go to the PassiveBuzzer. So you can actually hear, hopefully, the PassiveBuzzer. Now it's going through the SoundPlayer again. There is no SoundPlayer connected. We don't have that capability in the simulator, but it's still running through. The code will have absolutely no problem running through in the simulator because it uses I2S, which is built into MicroPython. So that's how you play sounds in using Pico library on the Raspberry Pi Pico using a fully object-oriented design. Hope this was useful and you learned a little bit. If you did, feel free to subscribe and I will see you in the next episode.